Hello students, welcome to Brains Gossip. So today's tutorial will try to calculate the number of cuboid that can be considered inside a Rubik's cube. So actually today's tutorial will be a continuation tutorial of my previous video. Now in my previous video you have seen that how we can calculate the number of parallelogram that can be considered if some parallel lines are crossing over to each other. So in my previous video you have seen that if there are three parallel lines and I am taking another set of parallel lines, and by some basic formula, mathematical formula, we can actually calculate the number of parallelogram that we can consider inside this shape actually. Now we'll try to calculate the number of cuboid that can be considered inside a Rubik's cube. Now in a Rubik's cube there are basically four different planes. Now suppose this is a Rubik's cube. Now there are basically three different axes. Now this is axis 1, this is axis 2, and this is axis 3, and there are basically four different planes. First plane, this is the second plane, this is the third plane, and this is the fourth plane. Now in order to consider a cuboid, we need to take three sets of parallel planes. Now first I am taking the first set of parallel plane, then I am taking the second set of parallel plane, and this is the third set of parallel plane. So this is set 1, this is set 2, this is set 3. Now I need to choose these sets of parallel plane among these four parallel planes. So I need to take a combination of 4C2. Again I am taking these two planes out of four different planes, so that should be again 4C2. Again I have to take 4C2 for the third plane. Now if I calculate, it will be 216. So as we can see, we can get 216 number of parallel plane, 216 number of cuboid inside a Rubik's cube. So that is the way we can actually calculate the number of cuboid that can be considered inside a Rubik's cube. Basically this is the three-dimensional form of our previous problem. Our previous problem was to calculate the number of parallelogram inside for crossing over two sets of parallel lines. Now here this is the same problem. This is the three-dimensional form of the previous problem. So the problem is really beautiful, so that I thought I should share with you. So that is the thing. Now if there are extra number of parallel sets, suppose there are 5, 6 or any other thing, then we can actually calculate by using the same formula. These four will be changed. There are four different planes, so that's why I have taken 4. But if there is any other figure, then we will just change the number, and will get the number of parallel planes, number of cuboid inside that geometrical figure. So thanks a lot for watching.